Okay, so good afternoon, ladies and gentlemen. So we will continue now pretty much what we were left in the last session or panel, and now I will continue about the solutions for future Arctic meteorology, and especially regarding space applications, so satellites and what can be done with those. So that's what can be done with the observations. As was discussed in the last panel, the lack of observations is one of the key issues, and satellites are the key of monitoring those kind of things. And now what I have here in this slide is actually kind of current and future situation, what is happening especially in Europe. I guess here in USA you don't necessarily know so much in detail what is the progress in European side of the Atlantic Ocean. So first of all, there are major players like European Union, European Space Agency, and EUMETSAT. So EUMETSAT is actually pretty much like the satellite part of NOAA in that way, but it's a combination of different countries, member states. So it's not the same members exactly as in the European Union, but it's an intra-governmental organization. So European Union is having their big Copernicus program in which they are launching Sentinel satellites. And you can say that they are currently the world's most prominent Earth observation program. So high number of satellites of high quality polar orbiting satellites which are highly relevant for Arctic applications. So it means high resolution satellites like synthetic aperture radar, which can be used for sea ice mapping applications, atmospheric missions, all kind of oceanic missions, sea ice missions. And that is going to continue for a long basis, so it's a sustainable program in that way. And there is also a dedicated polar mission under consideration for late 2020s. And there are basically two options for that. So multi-channel microwave radiometer or ice topography mission, which is kind of altimeter with which you can monitor the height of the Greenland ice sheet and that kind of things. And so in the case of microwave radiometry, it's kind of a gap filler because there might be problems in the US side for the sustainability and continuation of passive microwave radiometer observations, which have been like the main source of information for climate change investigations, so giving the information on the decay of the Arctic sea ice extent and concentration. So then the other major player in the Europe is European Space Agency, and they are actually providing the Sentinel satellites, so building those for the European Union. Again, European Space Agency is not the same as European Union, but there are independent member states which are constituting the agency. And it also makes the meteorological satellites for the EUMETSAT. And then there are several ongoing research satellite programs relevant for the Arctic. But additionally, there are plans for example, for this first here Canadian-Finnish cryosphere mission, which is currently in a competition for the so-called Earth Explorer 10 satellite mission. So it's about snow and sea ice. But that is, let's say, not clear whether it is going to happen because it's a competition between different missions, basically. But the Canadians, they are considering that as a national mission as well. So there are that kind of things. Then European Space Agency is interested in this highly elliptical orbit meteorological satellite mission. And there are studies going on, but unfortunately, I'm afraid that European Space Agency would not have money to build that by their own resources. So in that case, it has to be probably EUMETSAT, because European Union does not probably have the money to go on with that mission either. So EUMETSAT is probably the possible agency that can go forward with that mission concept. And that was discussed earlier, and I have some further information about that later on in my presentation. Then there are, of course, national programs. Canada is doing much. Norway is doing pretty much in the field of communication. So they are actually establishing probably this highly elliptical orbit mission for communication, not for meteorological applications, but to provide communication solutions for the Arctic areas. And as was previously discussed, also China is becoming pretty active in all these aspects, and so it's a kind of new country in that field. Okay, so that doesn't show up very well, so there should be kind of movie about that, but anyway, that was showing the highly elliptical orbit mission, how it rotates the Earth. But as was mentioned before, the problem in current geosynchronous meteorological satellites is that they do not observe well high latitudes due to their imaging geometry limitations. And because of that, it is needed as a gap filler. So this kind of mission would solve this handicap and provide continuous kind of imaging data for all meteorological applications and for other things as well, like telecommunications, positioning, which is a big problem in the Arctic areas as well, and of course for climate and environmental research. So we will see what happens in that, but there are definitely in the European part of agencies a funding problem regarding how to proceed with that thing. So I was mentioning that one candidate mission for future polar monitoring is this Finnish-Canadian-led initiative about radar imager to measure snow and sea ice, basically. And it is actually quite large consortium that is proposing the mission, including partners from USA, so JPL is part of that team. So we will see what happens in that. But in general, you can say that Europe is quite strong in the field of microwave radar imaging at the moment, and that is a kind of continuation to that. And Canadians, they are having much experience in that as well through their radar satellite programs. Okay, so then finally some words about what we are doing, especially in Finland regarding these things. So of course this highly elliptical orbit imaging would be highly valuable for us as well as for all Arctic countries. And we are, as I mentioned, there are investigations by European Space Agency to go further with the plans how to do that. And as I mentioned also, Norway is active at the moment regarding telecommunications. Then if you consider these Finnish applications, there are sea ice, snow cover, seasonal frost, permafrost, navigation. There are problems of navigation signal in the north, so positioning, accuracy. That is a very serious problem actually. Meteorology and climate research in general, Arctic mapping, space situational awareness. That was mentioned for the case of Alaska as well. Space weather is an important thing. So we have in Finland, we have a so-called Sodankylä Arctic Space Center, which is a kind of national asset for which we have in Finland invested pretty much for all kind of, let's say, cryospheric research and data reception for polar applications and that kind of things. So I will skip this one, but just go to the next one, which is kind of thing what we specifically did for this period of chairmanship in the Arctic Council. So that animation is showing a product that we are providing on a daily basis. So providing snow mass and sea ice concentration at the northern hemisphere. The sea ice concentration is coming actually from the EUMETSAT product of Norway, and the snow product is coming from FMI. So we are providing that snow mass information. And an interesting thing is that what is it based? It is actually SSMI-S microwave radiometer. That is a US radiometer on the Defense Meteorological Satellite Program. And the problem is that this program is not going to have new satellites anymore, probably in the future. So that was the reason why there is a consideration to fill that gap by a European microwave radiometer imaging satellite mission. So that's something let's say, pretty much crucial for the future decades, how to continue to get that kind of passive microwave radiometry for high latitudes. Okay, I skip the next one as well, but that is one interesting thing that we are also doing during this period of the Arctic Council chairmanship. So it's a kind of demonstration how to improve navigation and safety in the Arctic Ocean by providing real-time satellite data coming from high-resolution microwave radars, which are downlinked to ground station, in this case in this demonstration at Sodankylä, and then compressed and combined with other data like meteorological forecast information, and then transmitted by low-frequency ship of opportunity transmission system into the vessels operating at the Arctic Ocean. And this is supposed to be done in a near real-time manner, so ice situation with the delay of less than 1 hour to ship that is operating in the Arctic Ocean. So that is kind of a demonstration in which we are trying to combine this meteorology, Arctic imaging, and connectivity as well. So that is based on this low frequency signal propagation in the atmosphere. Okay, I will skip this as well. So this is about how the sea ice charting is done in general, and that is going to be used in that demonstration as well. Maybe to show briefly this one. So what would you need for these sea ice navigation applications? This kind of image, what you can see here. So it's traffic lights, what kind of trafficability conditions you are having at the Arctic Ocean. So here you have Novaya Zemlya, and here by different colors, indicating by using different data models and satellite data to assess what is the trafficability at that region. Okay, and that kind of things we are basically doing pretty much at the Baltic Sea at the moment based on the satellite data. Okay, thank you for the attention. So that concludes.
Thank you very much, Joni. Thank you. That's beautiful. Yeah. And now we'll have our second speaker, Arne Snorsen, please.
Good afternoon again. Now I appear here with my third hat, which is more WMO. So I'm giving a little bit of a sort of a global or WMO perspective of these things, but injected a little bit with conclusions from the discussion we've been having since we started this in Finland in last year. Just a little bit about WMO. We have mentioned WMO at various times here. Like Johanni said, this is an organization consisting of almost 200 nations, and it is well over 100 years old, and probably one of the most successful UN organizations. And this is because weather knows no boundaries, and it's a global thing. But WMO likes to be and is an authoritative voice on many of these issues that we have been discussing here. And in particular, they focus on observations and transmission of observations, and that was really the big challenge in the early days, to communicate the weather information around the world. But then with time, climate has been much higher on the agenda, and now in particular water. This is often forgotten that water is a part of WMO, but we can see that from the new leadership that water is going to be a key issue for WMO in the near future. So I will not go through the list here, but WMO is really a mother institute for all the Met services. They provide the standards, the methodologies, they provide the real-time communication systems. They provide and develop a lot of research in collaboration with the research community. And they promote activities in operational hydrology and, of course, collaboration between hydro and meteorological services. Actually, a fair number of meteorological organizations are also with hydrology, but still maybe 50 or 60 are outside of that community. And this is going to be addressed a little bit in organizational reforms at WMO that will be discussed at the next Congress next year. So it's really sort of the backbone of the international network of the Met services. One thing I like to mention is that, for example, they have a special task force on polar remote sensing observations, where all the agencies that were mentioned here, and actually a number of additional ones like India, and I cannot mention them all, but more or less all the national agencies and international agencies that are working on remote sensing, they work through this panel to come up with a sort of long-term vision on how to meet the requirements within the polar regions. And this is a very, very important task. And this, of course, has also facilitated the exchange of information at a higher level than ever before. I will also go a little bit over Job, even if it has been mentioned here, because I think this is really a sort of a breakthrough. It's called a year of polar prediction, and actually it's almost a decade, starting with preparation and then an intensive observational period that has just started. And this is done in great collaboration with the research community. EU is funding a lot of activities during this period. Same goes from Germany and China and many, many others. And the main goal here is really to, on one hand, improve the observational system, but also to improve the modeling capabilities. And with these two together, then you can optimize really the observational systems that you need. So this is the timeline. It started preparation in 2013, and now it's really in the midst of these intense observations. And then there will be a consolidation phase, and all this data will be available for any model experiments into the future. Sorry. This is a simulation of sea surface temperature in one of the models. But there are other initiatives by WMO that are in implementation stage. One is the Global Cryosphere Watch, which is really trying to operationalize cryospheric observations. And there is already a network we call CryoNet that is in implementation phase. And the idea here is to have this as a component of the global observing system of WMO. And these stations are supposed to meet the standards that are required, but also to have open access to data and in near real time. The coverage is already pretty good, but of course we are working very much on improving this coverage. There are still some gaps. But GCW is also sort of a center for disseminating cryospheric information. And many of the products that Johanni or was mentioned here earlier is available through their portal and webpage. And they have really focused very much on the interoperability of the data sets and data products that are available, addressing the problem I was describing earlier, that often this data is not accessible to the community and not nearly in real time. Another WMO initiative that was really initiated during the polar year is Arctic HICOS, which is really to serve as a vital platform for the regular collection and free exchange of Arctic hydrological data among all participants. The color code on the dot here, I'm sorry, the color code is not very visible, but we can see that the blue are the most recent, but from the continental areas, especially in Russia, we are not getting nearly the same level of information that used to be available. And this is a big concern because all this system is under great change, both the permafrost and the snow seasonality and the glaciers in the region. And this is impacting the inflow into the Arctic Ocean. And this is really one of the challenges that we will focus on, hopefully under the chairmanship of Iceland in the Arctic Council, to improve on the hydrological part and cryospheric part. Hydrological data is very sensitive for exchange, and even if WMO, which is one of its role, is to have standardized data exchange policies on meteorology, hydrology, and climate data, it's still very difficult to implement that at the global level. And as I say, hydrological data is in many places very sensitive because of other interests, but also because it's so distributed that it's not accessible to the general community. Well, we already had the presentation on remote sensing, and it's clear that already, of course, remote sensing is providing, I would say, most of the information on the Arctic and the changes taking place there. But to fill the gaps, it's still the most viable way. And hopefully new technology will provide solutions that are affordable for us. And I think even that was not necessarily mentioned specifically, but some of these missions, they should be international in character rather than national or regional like they mostly are today. So these are the key messages really from my both presentations and really from the discussion we have had at the science meeting in Helsinki and the summit. We like to base our services on science, and policies also have to be based on science. We need to identify the threats that climate change is causing in the Arctic, and we also need to understand the role of the Arctic in the Earth's climate system at all timescales. And actually this question is really generating the huge interest in the Arctic from non-Arctic countries, because they are already feeling the impacts of these changes on their own day-to-day weather, actually. enhance sustainable observations and modern big data management, a very challenging issue. Then, of course, maintain and enhance an effective stream of communication to the public and policymakers. Thank you very much.
Thank you very much, Arnie, for that overview of WMO. Very important and nice summary. Thank you. I'll have a question for you on that at the time, but thank you. And now we'll return to Carvin. We'll give the next presentation, please.
Thank you. I'm going to start off with a couple of 2 or 3 kind of points points of interest. You know, we talk a lot in the Arctic. We're concerned about sea ice, and those of you that have more than a passing interest in what we call the modeling of the atmosphere and the ocean, we're with sea ice modeling right now. We're about where we were with atmospheric modeling in the early 1990s, in terms of I'll call it the validation and the efficacy of and seeing the results of a sea ice model. Also, we talk a lot about, you know, in the I'll say the atmosphere and the water system, the hydrological system, and the ecosystem is sort of distinct pieces of I'll call it the global system. But we all know certainly that they're very closely tied together. And of course, one of the things that as I'm going to talk a little bit about here is the impact on our indigenous populations. Is that obviously the water that was melting right now in Alaska, and it's going to coming down the rivers, and eventually it works its way in most cases into the Bering Sea. In the Bering Sea, then, in that nearshore ecosystem is then the issue that where our indigenous populations are again harvesting both marine mammals and harvesting salmon. And so that becomes, as Louis, my boss, says, he talks about NOAA's role and the Weather Service's role in understanding, again, from the top of the atmosphere, and in our case, because of space weather, from the sun down to the bottom of the ocean, because they are interconnected. You can't disconnect, hydrologist Arnie there, you can't disconnect the hydrology from the meteorology, from the ocean dynamics and the ecosystem, because they are obviously tied together. And lastly, as we talk about the ecosystem, why that's important, and I'm going to allude and why I'm so passionate about in Alaska with NOAA's mission and the Weather Service's mission about traditional environmental knowledge. I was talking with the gentleman here on the side about why, you know, the impact to the ecosystem, how that impacts our indigenous populations, our subsistence hunters. As is told to me on many occasions, is that the ecosystem is actually the refrigerator for the indigenous population. And meaning that if you're a hunter-gatherer, fisher, harvester, that literally you're gathering berries and things off the tundra. You're certainly harvesting maybe caribou or moose or bear. You're catching fish. You're harvesting marine mammals. So if you contaminate that environment, then you contaminate the food supply. It'd be somebody like throwing bath water into your refrigerator. Any more you'd like that, then. So this is part of what's driving us in NOAA as we transform our mission and how we're delivering. So what kind of services we actually deliver in the next decade, because we have to, as we're going to talk about here, as things change, as we're meeting these changing needs, these requirements that's driving as we redistribute our resources, as we refocus our money, that those are the sort of answers we have to anticipate being able to deliver, and questions that are being asked. This is actually one of my favorite pictures. Those of you who have been in Alaska, it's top of Mount Alyeska. As you could probably guess, a Texan on skis is sometimes dangerous, but I actually very passionate about backcountry skiing. And so anyways, it's, again, one of my favorite places in the world to be. So the outline of the talk, we're going to talk a little bit about our mission and vision in Alaska, and how it really amplifies what the bigger piece of the bigger mission of the National Weather Service: protection of life and property, enhancement of national economy. Our leadership in Alaska has gotten together, and how do we make this real for our workforce and make it real for our the folks that live in Alaska and the folks that ply the waters and use Alaska for either recreation or business. We'll talk about new drivers. You know, I talked a little bit about the drivers, the things that kind of get us to what we're doing right now, but I'm going to talk a little bit about these emerging requirements. Talk about a little bit about partners, how we've started now. We've got an Arctic Testbed, and then we're going to talk a little bit about what we have named the Alaska Environmental Science and Service Integration Center, or ASIC, and then gaps and challenges and benefits and conclusions. So our mission statement, it's actually a little bit of an amplification, and this was all the leadership within the Alaska region. We came together and we looked and we wanted to make something that meant something that our workforce could own, and that the people in Alaska and the people who use Alaska and recreate in Alaska could understand. And certainly our vision statement here. And this is really the gist here. Those of you that have visited and certainly live in Alaska, I'm looking at Mike down there, that we look at ourselves as the vanguard to safeguard the last frontier. And we look at this as a national treasure. And part of our mission is to protect this national treasure. So again, same pictures here. I won't change this, but notice here, we've got what we see is sort of on what we're seeing now in terms of new requirements and emerging missions, and certainly here in the latter portion of this decade and into the next decade. Obviously the Arctic, it's not just Alaska. The Alaska is only a small piece of the Arctic, but what stays in the Arctic, what happens in the Arctic, it can also impact other portions of the Arctic. And so the Bering Sea, it's a huge issue. It's the crabbing kingdom for the world, literally. And it's also where a large portion of the indigenous populations in Alaska live in the coastal areas. Protecting the indigenous population, their refrigerator, their need for infrastructure, to build out infrastructure, doing it right. The possibility of what do we do with this? How do we, if a village needs to be moved because the sandbar is eroding, and what do we do with that village? Do we move that village? Do we do mitigation strategies? That is extraordinarily expensive, and we have we're not getting into ANSLA and the Alaska Native Claims Act of 1972, as I recall. We have as a federal responsibility to be engaged in that decision making, as well as the indigenous tribes themselves, and whether they move or whether we mitigate. So, and it's a huge cultural decision that needs to be made. So we want to be involved in the physical parameter and working with other federal agencies to ensure that we're doing this right. Ecotourism, that's only going to get more extensive in the years forward. The Northwest Passage, as I say, that seems to be one of the ways that folks want to be able to get into the Atlantic Basin, and certainly across northern Siberia and that eastern waterway that Russia now is expending a lot of resources and a lot of effort in order to encourage traffic on their side. But guess what? They come down through the Chukchi Sea, they come down through the Bering Strait, they come down through the Bering Sea, and they exit into the Pacific through our Aleutian Islands. So, and then coastal erosion is a huge issue, and it's only going to get worse. And this is and so that there is a weather forecast issue to this. There's a tactical forecast issue, but then more importantly, there is a seasonal, subseasonal, and a climate issue, questions that need to be answered. We have to be sure that we're doing have the right and the best scientific information, our best, I'll call it modeling estimates, so that the policymakers are making the right policy. Because these are investments that we're going to be making and potentially life-changing, cultural changing events that we're not going to have an opportunity to go back and have a do-over. So we have to be able to be sure that we can look back, we're making the right risk assessments, we're making the best decisions we possibly can with the right scientific information. Ecosystem prediction. Right now, there's harmful algal blooms, impact shellfish, impact the crustacean development. It impacts one thing we're getting involved in now is with national marine fisheries I guess what Dr. Gallaudet talks about, the blue economy. and talks about the harvesting of the kelp beds that are, which is now a burgeoning activity in Alaska. And the Arctic Homeland Security, I don't want to go delve too far in that, but the Western Aleutians is a battleground for trafficking in persons and trafficking in illegal sorts of substances and things like that. I'll just leave it at that. And so the Weather Service and NOAA is involved in that because the Coast Guard and the Department of Defense is concerned about these issues. And then again, these enhanced river forecasts. We have a very limited understanding of how much rain falls in Alaska. And for that matter, falls in the upper portions of the Yukon and into the Mackenzie Delta, into the Mackenzie River, which is in Canada. If you don't understand the Mackenzie Basin and what falls into the mouth and falls and actually drains into to the Beaufort Sea, you're never going to understand the characteristics and the dynamics of sea ice and the changes that are going on that impacts the ecosystem and potentially the food stocks that will then eventually impact the indigenous populations. So policy decisions that are being made about what we do with harvesting of fish and harvesting of marine mammals, or the impacts due to development and ecotourism and marine transportation, policy related to that is related to understanding, for instance, the Mackenzie River and what's going on in snowmelt and actually feeding into that Beaufort Sea, which then provides the antecedent conditions for the next sea ice year. So there's a lot of complex issues up there, and I think you've heard from both Arnie and Juhani about the lack of observations and the lack of being able to have enough observations and getting those and having robust enough models to then have predictive capability that will help us provide that risk assessment information folks need. Yeah, that's really critical. And again, there's no man is an island up there. We have to work together as a broad community. Okay, these are the drivers here. Again, this is new. This is all sort of new stuff here. We already talked about the INSAR, but there's also DOD's got, Department of Defense, pardon me, has an Arctic strategy. There's if you have read any of the news that's going on, Russia is spending a lot of money and a lot of resources to do a build-up across the broader portion of the Arctic. Coast Guard obviously has a strategy for the Arctic, not to mention, part of which is the icebreakers, which is multi-billion-dollar sort of investment over the next decade to 15 years. And again, the different sea routes how do you get to Rotterdam? How do you get to any of the seaports along the European coast? That's a big issue. It's a big driver. And notice here, guess where they're going. This is why obviously the PRC has a huge interest, because of the connection of how do you get here more quickly, more safely, and more efficiently. And then I've taken the time to actually read the Arctic this Arctic cruise, and then also if you've had the opportunity to read the People's Republic of China's national strategy for the Arctic. It's really interesting stuff. It's talking about a lot of the things that we're talking about here. But this is why it's a global community. This is not this is a global problem, the Arctic. So these are our local partners. Again, and this is just a few of them, and spans the Department of Defense, obviously WMO, the University of Alaska, all three campuses in Alaska. We have a lot of very close relationships with. And you'll see down here the Arctic Domain Awareness Center, and I know Heather's back there. I think Heather's back in the room. Again, we're very closely tied here. Arctic Domain Awareness Center is part of Department of Homeland Security and then U.S. Coast Guard to start looking at issues, environmental issues, to answer some of these homeland security issues that we see facing here in the high latitudes. So I won't spend much time on this. This is where we're at right now. Basically, we've got 3 forecast offices, both in Fairbanks, in Anchorage, and down in beautiful Juneau, where it rains 300 days a year. I have a picture of Juneau with the sun out, and we say we photoshopped that. But we also have the Tsunami Warning Center, and we also have aircraft support, actually a forecast unit in Anchorage that you can actually see here, the Alaska Aviation Weather Unit and the Center Weather Service Unit. and the APRFC. Actually, believe it or not, our River Forecast Center actually supports Hawaii. And that's a gig I wanted. I somehow missed. They get to go down to Hawaii and go down to various other places down in the southern hemisphere. It's the Pacific region of the Weather Service is over. So, but we're actually, and I'm not gonna talk anything about it, but we're actually transforming these little blue dots here at Utqiagvik or Barrow and Kotzebue, Nome, McGrath, Bethel, St. Paul, Colbay, King Salmon, Kodiak, Yakutat, and down at Net Island or Metlakatla. And we're transforming this, and we're using technology out of Finland, Vaisala Corporation. Those are actually essentially data collection offices where they're launching balloons twice a day, and we're automating that. And what you're going to see is, in this next portion of the slide is we're taking those resources, those folks that had historically been launching balloons, and we're what we're calling repurposing those jobs, and we're putting them into new sorts of activities to address these emerging issues we see going forward in Alaska in the next decade. One of the things we're doing we have developed an Arctic Testbed, and the Arctic Testbed right now is really focused on weather and water and ocean-related stuff. But where we see the Arctic Testbed going forward is, and I'm going to use those of you that maybe know or know of Meade Treadwell. Meade Treadwell is the former Lieutenant Governor of the state of Alaska, and he used the word cooperative federalism. And cooperative federalism, it really describes what we're trying to do in Alaska. And I'm going to talk here from a U.S. perspective. If we're going to do this job, and if we're going to transform, we need to do it correctly, and we can't do it as a weather entity alone. We can't do it as a NOAA entity alone. We have to be working together across the federal, the barriers that have historically separated us. For instance, with the U.S. Geological Survey or the Bureau of Land Management or the Forest Service. We need to work in a cooperative sort of way in order to address these emerging needs and requirements. And one of the ways we expect to change is through our NOAA's Arctic Testbed. Even though we're doing weather-related things right now, the vision in the next decade is to actually integrate the questions to, for instance, what we're doing with the crab fisheries right now with National Marine Fisheries is integrate what is going to happen to the crab stocks in the next 20 years if we have an indication that sea ice conditions are going to change and the sea surface temperature is going to change. That could drastically impact the red crab fisheries in, I'll say it, in 2025 or 2030. And so those are the sort of things we plan to, as our test bed evolves, to start trying to answer those sorts of questions. Or for instance, our subsistence hunters in Alaska, they harvest wild bird eggs, and some of which are protected species. And so how do we do this, and what are the projection? How do we protect those, I'll call it the seed corn, so to speak. How do we protect those migrating birds that might be near in the protected area? How do we give better physical information out in that seasonal area so that they're not over harvesting that would impact and cause a death spiral in a particular community? So this is, even though right now we see the vision, we've got 6 folks in our Arctic test bed right now, but we see this doubling and then integrating other federal agencies and state agencies inside the test bed to start talking about integrated testing and evaluation activities to deliver better so that we're not working from a weather perspective alone. Some of the things we're working on right now is, of course, sea ice modeling. It's near and dear to the hearts of all weather folks in Alaska. Because, again, interesting for, again, kind of a side note for those of you, I'm sure most of you are not meteorologists out there, but sea ice in itself is extremely important because of obviously, for instance, the crabbing fleet plays right at the ice edge. If you've watched The Deadliest Catch, you see that. But more importantly, where the sea ice edge then dictates where the freezing spray is at. Freezing spray, by and large, kills more, over the last 20 to 25 years, has killed more mariners out there than probably just doing something really stupid. And so so to understand and characterize the ice edge then is integrated into our forecast process so that we're actually doing a much better job. When I first came into the Weather Service 28 years ago in Alaska, we were doing much better with our sea ice forecast. And there's a lot of things that are contributing, but it's actually deaths due to freezing spray in Alaska have gone down dramatically, and not the least of which is due to the fact that we're doing a much better job of the ice edge and a much better job, hence, of forecasting freezing spray. So here's kind of the money slide here. We talked about the Alaska Environmental Science and Service and Integration Center. These are some of the goals, and I'm talking about the broader goals that we want to do within the ASIC. And if you can kind of think of it like an onion, the outer skin of the onion is we're going to improve weather services. We're going to do a better job. We're going to take those from those blue dots. We have 42 people actually that are devoted right now to launching balloons. We're going to take those 42 people and we're going to change them into different sorts of scientific professions to do a better job of forecasting, aviation forecasting, do a better job of sea ice forecasting. And then from that is that we're going to improve our service delivery within the state of Alaska. But then more importantly, as we talked about, this is using Meade Treadwell's phrase, cooperative federalism, we're going to do a better job within NOAA. We're going to embed National Marine Fisheries folks. We're going to embed National Ocean Service folks. We're going to embed folks from our uniformed services, our OMAO fleet, into this ASIC so that we're providing an integrated service delivery, so that when you get a National Marine or a National Ocean Service harmful algal blooms forecast, it will have weather service added value information integrated to the actual biological forecast, the harmful algal bloom forecast, which right now we tend to kind of operate more, I guess, we call them cylinders of excellence or in silos. And we're going to do it in an integrated sort of way, not a virtual way, but an integrated way. And then the outer portion, or maybe should say the inner portion, is at the end of the day, is that we're going to integrate. Our plan is to integrate, and we're actually in talks with USGS, BOEM, Forest Service, as well as the Fish and Wildlife Service about how do we sit down together and actually so that biologists can sit down and talk to meteorologists to create, so that we're adding value to their forecast, to their biological forecast, both in the tactical range and certainly in the seasonal, subseasonal, and in the climate range. So this is, again, that's the goal into the next decade of what we're going to do with this so-called ASIC. And notice here at the very end, our plan is to do a couple of things. We in the Federal Service, we have to be able to look at ourselves in the mirror and understand and to be able to articulate to those that are paying our salaries, our taxpayers, is what is the value of what we're doing. So that initially we're working with the Institute for Societal and Economic Research. They're out of the University of Alaska. As Dr. Louis Uccellini says, and what we're doing with Evolve National Weather Service is we have to understand the value of what we're doing and be able to articulate that to the taxpayer. And his words, and I'll paraphrase his words, is that that the value of that if forecast or meteorological information, if is not changing behavior. In other words, it doesn't matter how good the forecast is, how good the information is, if it's not changing behavior, then it has no intrinsic value. And so that's one of the things that we want to do, is to evaluate as we change, is to evaluate the service we're delivering. And then that will then dictate the science and technology we do so that we can actually change the service we're delivering. And then this is related also to the traditional environmental knowledge. I won't go down and talk in depth with that again, but we're using as a model here, we're working with Dr. David Scott, no relation that we're aware of, out of Canada, and we're using what's called Polar Knowledge Canada as sort of a model. What they've developed is a center at Cambridge Bay up in Nunavut, working with Inuits, and is to I hate to use the word flyover science, but we in the scientific community tend to, in the Arctic, tend to fly in, do our research, extract our information, and go back to AGU or AMS, American Meteorological Society, or whatever society you're a part of, to deliver that information, and it becomes sort of a flyover effect. And what they've done with PRC is they're embedding in the local population with at this Cambridge-based science center. And and the light went off in my head when I saw what they're doing. And so we're actually working with PKC, Polar Knowledge. We're going to call it Polar Knowledge Alaska, pretty original. And since they're focusing right now with the Inuit population at Cambridge Bay, our largest Inuit population in Alaska is, of course, at Utqiagvik, or in Barrow. So we're talking, and we have infrastructure up there, and we're talking about mirroring that on a much smaller scale to demonstrate success, where we're going to talk about not just weather service and weather, but maybe in NOAA and a broader federal response, and to take advantage of what's already on the ground too, and then leverage what PKC is doing to then start this feedback loop and to integrate our activities into the local community, and then to get this, I call it the TEK feedback loop started. So that's sort of the short answer, and really kind of there's a lot bigger story, of course, here with the ASIC, but the goal is a center in Alaska with outlets at the various indigenous populations. So again, these are gaps and benefits. I'm sure the slide deck will be available. There's a lot of reasons we're doing it, as you can see here, and I won't go into the details here. But at the end of the day, again, this center, our goal is to create a new level of collaboration, because the real key here is consistency and relevancy of products and services, not just in the weather service, but across the whole federal spectrum. And then, as we say, to integrate this and unify weather, water, ocean, ice, and ecosystem, because it is a whole, from a holistic approach, as opposed to talking about, again, cylinders of excellence. Because the Arctic region's evolving. It's not just Alaska. We know this. And at the end of the day, decisions and actions are based on sound science that support the healthy, productive, and resilient communities and ecosystems. So that should be it. Thank you.
Thank you, Carvin. You covered a lot of territory, and you'd probably attribute that from being from Alaska. So thank you very much for that. And now our final speaker for the second panel will be Jack Kay from NASA.
All right, and I don't have charts, so I'll do this from here. So I guess I'd like to start out by thanking the Wilson Center for convening this and giving me the opportunity to be part of such a wonderful panel, and also thank the colleagues from Finland for the work that they've been doing as chairs of the Arctic Council, and in particular FMI for the work that they did this year in convening the Arctic Meteorology Summit, and also hosting the senior Arctic officials meeting, and nothing else from a purely personal point of view, giving me the opportunity to come to Finland in March when there was a lot of snow on the ground, which was a great joy for me. In talking about where NASA fits into this picture, I'll start out with a caveat that I'm going to speak to the Earth Science Division at NASA. We have multiple divisions within the Science Mission Directorate, and there's two other divisions that could contribute. One is the Joint Agency Satellite Division that actually implements the operational polar and geostationary missions for NOAA, for which they hold the resources and requirements. And we also have the Heliophysics Division that does space weather and ionosphere. So I'll talk about NASA Earth Science, which is sort of like from the stratopause on down to the surface. But that still gives us a lot to work with, and actually underneath the surface too. You could say that at NASA, more than anything else, when you think about what we're doing for the Earth and Arctic in particular, say we bring new kinds of global observational capabilities to the nation and typically to the world. And I think you only have to look back over the past few years at some of the new kinds of satellite observations that we've launched into high latitude orbit or polar synchronous orbits that'll get information that's really relevant to people who are looking at this particular part of the world, whether it's orbiting carbon observatory getting column CO2, global precipitation measurement mission getting precipitation with rain and snow, soil moisture active passive, the SMAP mission getting soil moisture and for wireless and freeze thaw information. Because so much of what we do is in these high latitude orbits, and especially polar sun-synchronous orbits. Not everything, in particular in the past few years we've been making more extensive utilization of the International Space Station, which is in a 51.5 degree inclination orbit. It's a wonderful orbit for a lot of things, but studying the high latitudes is not one of them. But that's okay. one of the particular things about the Arctic is the convergence of orbits. As the satellites go around the Earth in your polar orbit and the Earth turns, it means you're over the Arctic, 14 to 16 times a day, whatever it is, for those particular satellites. So that gives us good coverage and the opportunity to get a lot of observations that otherwise would be very difficult to be able to get. And the idea of really being able to see the Arctic, recognizing there's clouds, which create some issues, but not if you work in the microwave, but that you get the opportunity to get coverage in ways that would be very difficult to do with any kind of in situ sort of thing. And I guess I would miss and say, talk about the convergence over the orbits in the Arctic. That's true for the Antarctic too, but so different audiences I talk about the Antarctic, and I'm not supposed to say we're bipolar, but most anything that I say for the Arctic, I could say for the Antarctic as well, given the differences between them. While I'm here, something sort of focusing on Arctic meteorology, we don't really have an Arctic meteorology program per se. What we like to think of what we do is we have an Earth system science viewpoint, and we look at the Earth in its entirety. So that means we're looking at the atmosphere, we're looking at the ocean, we're looking at the ice, we're looking at the land surface, we're looking at what we can below the surface in an integrated way, and not just trying to understand the Earth system components, but the mechanisms that couple them. So that means we look at physics, we look at chemistry, we look at biology, and in the point of view of the Arctic, we really look at the whole Arctic, whether it's the U.S. part of the Arctic or some other parts of it, oceans, land, whatever, to a good extent, the satellites see all, and to a good approximation, the data are just as good anywhere as anywhere else. I say approximation because we have a responsibility to validate our products and our algorithms under what may be some very different sets of geophysical or biogeochemical conditions, whether it's in the Arctic relative to the rest of the Earth or different parts of the Arctic. And if you look at some of the things that we've done in the past or that we're looking to do in the future, I think you can get a sense of that. So you go back to 2006 when we launched the CloudSat and Calypso satellites. So what that meant was we were getting in polar sun synchronous orbits as part of the A-Train, three-dimensional cloud and aerosol profiles over the planet, and those three-dimensional cloud profiles over the Arctic is something that's very hard to come by before. And when you start trying to look at the meteorology, having that climatology and the sense of variability, I think, has the potential to be really important. The rest of the A-Train has given us a lot of information, including aqua for sort of basic physics and temperature, moisture, and aurora for atmospheric composition, and a variety of other things. And looking ahead to the future, future sort of, we just, following 15 successful years of the GRACE satellites as a partnership with Germany, just last week, we launched the GRACE follow-on mission for gravity measurements, but the ice mass measurements at high latitudes have been one of the major things that the GRACE missions have done in the past, and we look forward to GRACE follow-on doing that again later this year, in September or so. ISAT-2 for measuring ice sheet thickness is due to get launched, and looking further into the future, NISAR is a radar mission with India. Okay. So, there's a lot with the satellites, but it's not just satellites. There's a variety of things that we'll do with surface networks. In particular, the Network for Detection of Atmospheric Composition Change has a number of high-latitude stations, I guess, Thule, Alert, some others, others that, some we provide the instruments, some the host nations. So Donkola is an important station for that. We do a lot with aircraft, which give us the opportunity to get sort of focused measurements with payloads that may not be able to do from satellites. So in the past, number of years, we've been every year, at least once a year, going to the Arctic with Operation Icebridge. A number of years ago, we did the RISE campaign very in a disciplinary way to try to study the radiative and cloud properties of the Arctic, looking over sea ice and over areas that weren't covered by sea ice. A number of years ago, we did the IceScape campaign, looking at biogeochemistry of the Arctic Ocean in regions that had ice and didn't have ice, and more recently, from our Earth Venture suborbital program, the OMG Oceans Melting Greenland, looking at what's happening at the ocean ice interface in Greenland, dropping sensors into the ocean to get temperature profiles, and also doing bathymetry and doing airborne radar observations. And then we also do modeling, assimilation, and reanalysis, and I think trying to, like the Mirror 2 reanalysis, will have information that there's a lot of interest in what that's showing about the Arctic. We treat it not as sort of a separate set of approaches, whether satellites and surface and airborne, but we really try to integrate the techniques in a coordinated way, both in terms of calibration and validation and complementary science. And there's a particular focus in some cases on addressing complex scientific issues. So a few that have been mentioned earlier, like snow on sea ice. So not necessarily a meteorology thing, but it's a hard thing to deal with that remote sensing, I think, is very valuable for, because otherwise it's very hard to imagine how you could really try to build up the information that you would need. There's very few of these kinds of things that we talk about that we actually do by ourselves. So the linkages that we have with our interagency partners, with our international partners, are really critical to what we do. So in the U.S., it's sort of lots of ways that we have with interacting with each other. I see some friends out in the, colleagues out in the audience from some of those, whether it's the IARPIC, USGCRP, Subcommittee on Ocean Science and Technology, on the weather side through the Office of Federal Coordinator for Meteorology, or the Earth System Prediction Capability. We're all sort of working these same issues differently, and internationally, there's a variety of activities: Committee on Earth Observation Satellites, the Coordination Group on Meteorological Satellites, that's where I'll be next week. World Meteorological Organization was mentioned earlier. They have an expert team on satellite systems, the Group on Earth Observations. So a lot of these things that we do, because as was pointed out earlier, in the satellite world, our international partners are doing an increasingly larger share of what's being done globally, so it just makes good sense to coordinate, and we do. And there are some particular areas of strength, so like a really productive collaboration over the past number of years has been with the European Space Agency. They have their Cryosat-2 satellite that does radar measurements for ice thickness. So when we do our Operation Icebridge, we try to specifically underfly the satellite and get some of the Cryosat lines. And over a period of years, it's been probably tens of thousands of kilometers underflight that have been done. So we get it's complementary, because we'll have LiDARs and radars, and they've got the radar, and it's calibration and validation and enhanced science. And then all the data that we produce are made widely available, and whether it's sort of through standard approaches for through our distributed active archive centers, or through some products that are sort of more routinely available and designed to be more easily accessible, such as some of the Arctic conditions that come out through the Distributed Biological Observatory. At NASA, we also have the privilege, I guess, or rare opportunity among space agencies to also be science agencies. So we have a lot of competitive opportunities for people proposed to be part of our programs, to work with the data, to be part of our disciplinary programs. So we have a disciplinary program in cryospheric science. We have physical oceanography. We have ocean biology and biogeochemistry, atmospheric chemistry modeling, and the Arctic is part of it. The cryospheric science, obviously, the Arctic is a big part of it. And there's some specific things that we've done. We have an interdisciplinary science program. So in the past number of years, we've done sort of environmental impacts of melting ice, physics of the ocean-ice interface, sort of the dynamical connections of effects of melting ice, changing ice conditions in poles on mid-latitudes. And most recently, we had a specific interdisciplinary topic on methane, which, while not Arctic focused. The Arctic is a big part of it, and a number of the proposals that we selected were Arctic related. Going back even further, for a number of years, our Land Cover Land Use Change program sort of was a lead sponsor for NISPE, the Northern Eurasia Environmental Science Partnership Initiative, and we're currently evaluating a number of airborne proposals from our Earth Venture suborbital program that, some of which may end up being Arctic, but they may not, because we've got a bunch of proposals that we'll evaluate on their merits. We do have a technology development program through our Earth Science Technology Office that has a variety of things in terms of component technology, instrument technology, data systems technology. There are also some demonstration projects of what's normally called CubeSats, but we're actually getting some of these CubeSats out of our sort of the mainstream flight program, and one of the ones that we selected in the most recent round is called Pre-Fire. It's a 2 CubeSat mission. PI is Tristan Lecrae at the University of Wisconsin, but it's designed to do far infrared measurements, and it's a lower cost mission, so it can't do everything that could be done with those far infrared measurements, but their focus is actually looking at the Arctic to really try to understand the far infrared emission that leaves the Earth system and gets out from the Arctic, because the far infrared is historically probably the least well understood and exploited part of the electromagnetic spectrum from the Earth. And we also have an applied science program that their main foci are in ecological forecasting, health and air quality, disasters, and water resources, and they will look at it. There's not a specific regional focus to it, but they'll try to have a portfolio that will address things. And looking ahead, it's important to acknowledge the decadal survey. We just, this past January, our national academies released the latest decadal survey, I guess, Thriving on a Changing Earth, that sort of lays out a program for us, and it also has components for partners at NOAA and USGS, but there is some specific tasking for the different agencies. So for us, it was really not to give us a series of missions the way the first decadal survey did, but to sort of lay out a series of observations that they think that we would need, and some principles for implementing our program. So they designated something that what they called designated observations, 5 things that they said you should really do these through cost-constrained missions, and then explorer missions where they said through sort of cost-capped intermediate cost missions where there's 6 ideas and you should compete them and try and do 3 in a decade, and then some incubator things where they said, well, so to help accelerate the technology so that maybe by the end of the decade some things that we don't think that are ready for missions now will be ready, as well as continuing our Earth Venture program and also having Earth Venture continuity missions. So there's a lot of work that we've been doing to sort of respond to that decadal survey, and we're just sort of at the early stages of that. A lot of internal communications within NASA, communications with our centers. On May 10th, we did a major community forum, and I think had several hundred members of the community that were participating by webinar, and I think the idea is to do those every 4 months or so. So if we did that in May, the next one will likely be in sort of August, September timeframe, where we can share what our ideas are for how we're going to respond to the decadal survey, because that's going to have a really important influence on what we do over the next decade. And with that, I'll stop.
Great. Thank you very much, Jack. And thank you, all the speakers. You've enthusiastically used a fair bit of time, and I apologize to the audience for that, but we will try to get some very quick questions, short questions, and some short answers. And I'd like to start with one question to each of you, very short responses, please, if possible. And then I'll ask one question in common to all of you. And I'll start with Uni. You talked about a lot of the satellite programs, and you were kind with regard to your comments on the U.S. You mentioned maybe the passive microwave decay, but what would you like to see if you had the ability to encourage the U.S. to do something more? What would be your top choice for additional participation? And
Well,
please use the microphones.
Okay, yeah. So what I mentioned there was this sustainability, and of course, in the case of passive microwave radiometry, that is definitely the case. Then, if you consider something else, I was mentioning and previously as well, this high elliptical orbit imaging missions.
Risk.
So that is quite clear, because then you have that kind of imaging capabilities that are for lower latitudes, but not for the higher, and you can combine that with other scientific goals as well, so maybe greenhouse gases and that kind of atmospheric composition kind of things.
And JPL will be part of that. Okay, so you want to see a healthy participation by them in that.
Yeah.
Okay. Arnie, you mentioned quickly in your presentation of YOP that one of the outcomes will be to strengthen the search and rescue services. And I was curious, how specifically will YOP contribute to improve search and rescue services?
Well, the goal of YOP is to improve really the forecasting capabilities in general in the Arctic. And what we would like to see is to have a unified approach in that, a seamless approach in that, and that would make things simpler in our view. But YOP is contributing in the way that it will improve our capabilities of forecasting in the region.
So a standardization will be critical across the various nations.
Yes,
Okay.
and seamless sort of over the land and sea. Of course, there are designated areas today, but that would ease all synchronization for
Okay.
any search and rescue.
Thanks. Carbon, you said something about you've been passionate about your discussion on the indigenous topic here and Alaska Natives, and you say that the National Weather Service wants to develop culturally sensitive social science services and integrate TEK, traditional environmental knowledge, into National Weather Service operations. My question to you is, does the National Weather Service ingest or take observations from Alaska Native communities outside of perhaps some of the field offices and actually use those data to help improve forecasts or otherwise? Or is it just the focus is, well, here, we're going to give you something that's useful to you? Do you also receive data that are useful?
We do in one aspect, and it's related to sea ice. Without going into details, things like the sea ice walrus outlook, which I know you're aware of, we are actually subjectively ingesting
There you go.
the information from the elders and the captains out there that we get back in a near real time sort of time frame that we're learning to use, because a lot of the information is very granular, spatially granular, and we're, even from a satellite perspective, whether you're dealing with synthetic aperture radar or scatterometer data or passive microwave, it's much coarser. And so trying to figure out how to use that information is been sort of, I won't say it's a challenge, but we've learned how to use that. So the answer is, the short answer was yes, we do, but it's very, very limited.
Not a standard product by any
Definitely
means.
not.
Right, okay. Jack, for those of us in the audience who aren't experts on the Orbital Carbon Observatory, Mission 3 specifically, what is that going to do for us? What will that tell us specifically about carbon dioxide? How specific sources, sinks? Tell us what it will do.
Okay, yeah, so the OCO3 will be, from an instrument point of view, will be very similar to OCO2, because it was really produced through a robustly spared mission. And right now, that's due to be launched in early 2019. That'll be a payload on the International Space Station. So what that means is it's lower in altitude than the OCO2 is, and it's an inclined orbit, so it's a 51-degree orbit as opposed to polar sun sink. So that means it won't go over the poles, but because it's an inclined orbit, it precesses over time. So that means over a period of time when we'll be able to look at a variety of local times, which we don't see. I believe it's also targetable, so it will provide some ways for us to, the people operating, to be able to look a little bit more intently at specific areas, as opposed to just collecting data all the time. Because I think with OCO2 they have been able to see some things that were differences between sort of the higher CO2 associated with metropolitan areas and lower CO2 associated with the surrounding areas. But with those CO2 especially, I think the intention was less to be focused on sources, but more to be looking globally, especially to be able to try and get some information about global sinks. And I think with those CO3, there may be a little bit more of an opportunity to focus more on sources as well. So the complementary orbit natures of those two, I think, should really provide some opportunity for synergies, both among ourselves and then continuing to work with others who, international partners who have, also measuring CO2 columns, whether that's, partners in Japan and, ultimately, Europe and China as well.
Okay, thank you. So just to remind the audience, we have 10 minutes left. We have a hard stop at 4:30, and I would please ask that those of you planning to go to the embassy, the Finnish embassy reception afterward, the staff here from the Wilson Center will guide you to the shuttle. And then from there, you're on your own, but it's a one-way trip to the embassy for sure. So eat a lot and drink a lot. My question that's in common to all of you, and this is out of respect for the ambassador, because I want to return to the Arctic Council's theme of this, which is exploring common solutions. And I had a sidebar with Carvin before this. So what are some specific examples, even simple ones, that we could do collectively, at least the Arctic states represented here, to improve Arctic meteorology collectively? Because we've had a lot of individual talk so far, but what could we do as a group to advance Arctic meteorology consistent with the theme of the chairmanship? So let me start with Carvin, since he and I had a chat on that in advance.
Okay, I'm going to add on to some of the discussion that we, being careful of the time, is demonstrating success is so important. And one of my observations being in Alaska and certainly being in the weather services of all the scientific organizations seem to work more closely together internationally. And I would suggest that we start looking at some low-hanging fruit about how to demonstrate our ability to work together to provide as a potential baby step for how we could have a truly Arctic collaborative relationship. Certainly there's the North American Ice Service, and there's other instances. But having something simple like a weekly call between the Arctic nations, and that would be run every week by a different organization so that the burden wouldn't be on one, write a short, I'll call it maybe a half a page summary to talk about impacts, storm impacts, where the high impact weather may be occurring, with the purpose here, and then publishing it on WMO or whatever websites it might be. And the goal here would be to demonstrate how we can work together to as a template going forward on something that we do on a daily basis, which is to collaborate internally.
So you spread it out on a weekly basis?
On a weekly basis, and writing something up that could be published. And then it could be a resource and a demonstration project, simple demonstration project that would cost nothing more than a little bit of time. And then number two is that, I know Arnie was talking about search and rescue, is that there's these large international search and rescue sorts of activities, tabletop activities, is that we could do this as a meteorological group virtually. We could run tabletop activities to talk about, for instance, a shipwreck or a ship in distress or a spill or whatever the case may be, and do nothing more but having a concept of operation is to say we're going to do this through WebEx or whatever, Google Hangouts or whatever it is, and we're going to have some deliverables of how we might possibly work together without having to involve the constituent countries, Coast Guards, and but just to do, how would we, if something bad happened, how would we work together? How would we actually participate to come up with this collaborative solution?
Okay, so Arnie and Juhani, are you guys ready to have that weekly call? Yeah. All right, good, we're making progress. Thank you. Arnie, how about you?
Well, along similar lines, I think the example of the Arctic Polar Climate Center is really a collaboration of this nature. And it's now in implementation phase, but it's exactly the same type of sort of work sharing that is being discussed there. not only distribution among the countries, but also within the year or within the time periods. Someone is leading at this time, and then that rolls.
Rotating it
Rotating.
and strengthening it.
Another thing I like to mention, and that's the initiatives of the Nordic countries of joining forces regarding NWP, numerical weather prediction, and the HPC, the infrastructure needed for that.
Why don't you tell people what the HPC is?
High power computing,
Okay.
high performance computing.
All right.
And actually, we have extended this to the Baltic countries, but both the Netherlands and Ireland are interested in joining this, and this is really taking us really as a prototype for how our community can really work together. And I would like to see something like this happen around the Arctic. Yes.
Thank you. How about you, Uni? What do you have?
Maybe good progress could be obtained quite simply by more effective use of in-situ observations for these satellite Calval kind of things. So networks combining data from different continents of the circumpolar areas. So there are good examples that that kind of things is happening, like NASA is doing with SMAP and OCO2, but that can be extended to more missions and in order to improve, and that would be quite easy to accomplish.
So the data are there. It's just a matter of trying to integrate it.
Yeah, more or less.
Okay. Jack?
Two things that I could think of. I'll cheat and do two.
Keep it short.
Yeah, I'll try. One, and both are things that are already getting done to some extent, so I think it's not a matter of something new, but something, more full. One is data sharing, especially as more nations get into the global observation viewpoint. Data shared is so much more valuable than data hoarded, and if in some sense, it's free Calval. You can, you put it out there and you put it out with the caveats, and it's like, don't publish it, prematurely, and don't run off and publish it without consulting with us, because you may be looking at noise, not signal. But the more the data are shared, the better off we all are, and that's certainly true in the satellite world. And I think also when one looks at some of the field work that was talked about, trying to find ways to leverage things, joint campaigns where we can, putting instruments on each other's aircraft. That's not always easy, just to get the appropriate permissions to do that. In 2016, I think we did an air quality related campaign in Korea and had 5 of their instruments on our aircraft. I don't know that we ever had more than 2 instruments, foreign instruments on our aircraft, and coordinating ground measurements where it can, and also facilitating overflight, so that if one is doing airborne campaigns, the more that you can sort of just, if you're going after a phenomenon, you hate to stop at the border, because, geophysical or biogeochemical properties rarely stop at borders. It's fine for the satellites, but it's not fine for the aircraft if you don't have that permission. And hope is that maybe the work from the Council Scientific Cooperation Task Force that was done in the past years, maybe we'll be able to facilitate all of those kinds of things in the future.
Yeah, and thank you for that. I mean, Icebridge is a perfect example of not going even into the other sector of the Arctic. But you're right, this new International Science Cooperation Agreement has now entered into force as of May 23rd, and it does facilitate access to data, and it does have specific words about overflight too. So I think we need to exercise that agreement, and hopefully it'll lead to better cooperation. Let's take one from the audience, please. Sir, there's a microphone behind you.
I'm Peter Humphrey. I'm an intel analyst and a former diplomat. Something like the Fleet Numerical Weather Center is basically reproducing a lot of what's done by NASA and NOAA. And as a taxpayer, that always bugs me. But I recognize their job is to be ready to go to war in 1 hour. And I'm wondering if collaboration with the military is resulting with, are they just taking, or are they giving too? I mean, they have unique data points from the defense meteorological satellites, from ship transits, from sub-transits, from airstrips, coastal airstrips, and so forth. So how happy are we with the degree of sharing between the civilian and military community? Could we get more if we asked the military to give us all their week-old data, which would help a lot in the climatological studies, but not the tactical military concern?
Yeah, I think we get it. That sounds like it's for you, Carvin.
Yeah, good question. Haven't spent.
That question might be more for
Yeah, I was looking out there. I was looking at you, and yeah, it's a great question. I think I could say Dr. Gallaudet is, having been retired 32 years in the Navy, and that's one of the things that we're looking for when we talk about cooperative among the meteorological services, the National Weather Service, the CNMOC, Commander Naval Meteorological Oceanographic Command, and AFWA, Air Force Weather Agency. There is a general sense that we have to work more closely together instead of having distinct models, it's the geophysical atmosphere is the same regardless, and so there's a better, the cooperation is a lot better, and certainly between the Navy and the Weather Service. It's happening with AFWA now. So I understand there's classified side in terms of tactical decision aids and things like that, but I think we're working through that. It probably, again, I'm looking at somebody out there who would be much better qualified to.
I can tell you that obviously today we share all of the DMSP data. We declassified that several years ago. But as you've heard, DMSP is being phased out, 17 and 18. Once they fly out, they will be done. Increasingly, the Air Force is going to start working with commercial partners to buy data. And there will be some changes in data sharing in the future. Right now, we share data pretty openly, but with the new national defense strategy and us going back to peer-to-peer fight, we're looking at restricting some of our tactical data in particular. As you probably discovered, when you buy a Fitbit with Bluetooth on there, and the bad guys can see soldiers running on the track in Afghanistan, when you place tactical weather centers into that part of the world, and the metadata is relatively available to everybody, you can pinpoint very quickly that there's a military operation going on. So you can see that we're going to start restricting a lot of the deployed data. And as you know, the Navy today still classifies all shipboard objects.
Yeah.
Well, thank you very much. I'm sorry, but we're out of time. And so I'd encourage those of you who still have questions to ask the speakers on the way out or at the reception tonight. And I want to thank you, gentlemen, all very much for a very interesting presentation and dialogue. Thank you so much.
Thank you.
Let me also thank Ambassador Halkonen for allowing us to participate with the chairmanship. All of our panelists for the reception now at the embassy. Brody Ladd is outside of the door there, and we will lead a procession out to the shuttles for the reception at the embassy. Thank you all for coming, and thank you for watching online. We appreciate it.
No.